Hey everyone. So, if you've ever played around with Python, you've definitely used a list, right? And you've probably grabbed an item with a neat little index. It's super simple. But then you try that exact same thing with a set, and bam, you get a type error. It's a common point of confusion, but I promise you, it's not a bug, it's actually a key feature. Today, we're going to solve this little puzzle together and really unlock the power of Python's sets. So let's just put the main question right out there. Why on earth can't you access items in a Python set with an index the way you do with a list? Understanding the answer to this one question is really the key to knowing how and, more importantly, when to use sets in your code. Okay, so let's get into it. Just because you can't use an index, it doesn't mean your data is trapped in there forever. You can absolutely get to the items. You just have to go about it a different way. And that way is called iteration. And here it is, the big reason why indexing doesn't work. Python sets are fundamentally unordered collections. The best way to think about this is to picture a list as a bookshelf. Every single book has a specific numbered spot, right? You can easily say, hey, give me the book from spot number 3. But a set is more like a bag of marbles. You can't ask for the third marble because there is no first, second, or third. They're all just jumbled in the bag together. And if there's no order, there can be no index. So if you can't just ask for an item by its position, how do you see what's inside that bag of marbles? Well, you just take them out one by one and look at them, right? In Python, we do that with a for loop. It's the main tool we use to go through and work with every single element inside a set. Let's look at this super simple example. We make a set with apple, banana, and cherry. Then we use a basic for loop to print each item. Now, pay close attention to the output. It prints all our items, sure, but look at the order. We might get cherry, then banana, then apple. And get this, if you run this exact same code again, you could get a totally different order. This perfectly shows that bag of marbles idea we were just talking about. The contents are there, but the order is not guaranteed. Okay, so we've spent some time on what a set can't do, but now let's flip that around and talk about its real strengths. You know, every data structure in Python has something it's really good at. For sets, that special skill is something called membership testing. This is its superpower. So here's the bottom line. The number one reason to use a set is to very quickly check if something is inside it. Think about questions like, is this username already taken? Or is this product ID in my database of sold items? For these kinds of yes or no questions, sets are absolutely the perfect tool for the job. And how do we actually do this check? It's incredibly easy. We use two simple keywords, in and not in. So on the left, if we ask Python, is banana in this set, it comes back instantly with true. And on the right, if we ask, is grape not in this set, it also returns true. It's so direct, easy to read, and most importantly, it's unbelievably efficient. Just how efficient are we talking about? Well, this is where computer science gives us this cool little label O of 1. Which is pronounced big O of 1, or you can just call it constant time. Now, don't let that term scare you. All it really means is that it takes the same tiny, constant amount of time to check for an item, whether your set has 10 items or 10 million items. It doesn't have to look through everything one by one like a list would. It just, somehow, knows exactly where to look. It's practically instant. This speed is the whole reason developers choose sets for these tasks. Now, that incredible speed we just talked about is only possible because of another important concept. Besides being unordered, sets also have to follow a critical rule, the rule of immutability. So what does this mean? It's simple. Once an item is in the set, you can't change it. You can't alter that item itself. So if you have the number 5 in your set, you can't just reach in and magically turn it into the number 6. This rule is what allows the set to do its magic. Because each item is unchangeable, the set can reliably figure out where it's stored, and that's what makes those instant O1 lookups possible. It's all about keeping things stable. Now, immutable doesn't mean the set is frozen in place. While you can't change an item that's already in there, you can definitely modify the set as a whole. You can add brand new items, you can remove items that are already there, and you can even combine sets to create totally new ones. You just can't perform surgery on an element that's already inside. All right, so we've covered the what and the why behind sets. Let's wrap all this up and put it into a nice, clear guide for how you should be using sets in your own projects. So here's your game plan. First, always play to a set's strength. Use those in and not in keywords for lightning fast membership testing. It's what they're built for. Second, when you do need to process every single item, use a for loop to iterate through them. And third, always keep that rule of immutability in the back of your mind. Plan your code knowing you can add or remove items, but you can't change them once they're in. And we'll end on this fantastic pro tip. So what are sets really perfect for? Two main things. Getting rid of duplicates from a list, because by their very nature, sets can only hold unique items, and of course, performing those super fast membership tests we've been talking about. The big takeaway is simple. If you need to guarantee that all your elements are unique, or you need to check for things with maximum speed, and you absolutely do not care about the order, then a set is your new best friend. So next time you're coding, which one will you reach for?